Hello OpenMaze experimenters, I'm Kyle Alsbury-Neely, and in this tutorial I'm going to show you how to create local enclosures within your environments. As you can see, I already have my Unity editor open, and I have the enclosures configuration file docked next to it. You can find this configuration file in the tutorials folder of the configuration files folder. And for this experiment, we're going to add both of our tutorial environments to our build. You're just going to go up to File, Build Settings, and we'll open our first environment, add that to the build, open our second environment, and add that to the build as well. Then we can go back to our launch experiment scene. So for this tutorial, we have a configuration file, which is essentially a Morse water maze task, where first the participant is instructed to find a goal within an enclosure when it's visible, and then they're instructed to find the goal within the enclosure when it's invisible. And you can think about this like a Morse water maze task, where first the platform is visible and then the platform is invisible. So let's take a look at how this works. We have block 1, which is going to first present a locate queue, trial 2, where we have our visible goal, and then trial 3 with our invisible goal. So the participants given 2 opportunities to see the goal and then 2 opportunities to find the goal when it's invisible. And the block ends with trial 6, which is just our end screen. So in order to add an enclosure to a trial, first what you have to do is you have to add the enclosure line to your trial. So as we can see here, we've added enclosure 1. And the number next to enclosure is just the index number of the enclosure. The enclosures can be found in the enclosures section below. So we see here we have one enclosure that's built. So let's just go ahead and run this experiment and see what happens. Again, you're going to go to Tutorials, Experiment Configuration, and Enclosures. Go to the game screen, click anywhere, and then press the spacebar. And as you can see, when we're placed into the environment now, we have this enclosure. And we also have our visible goal. And when we run into the goal, we collect it. And then the next trial starts. So let's just pause the experiment and see how we're generating this enclosure. So enclosures have a bunch of parameters that you can play around with and tweak to customize enclosures. For this one, we see that enclosure sides is equal to 40. And basically the enclosure sides just dictate what the shape of the enclosure is going to be like. So in this case, we have 40 sides around our enclosure. And let's just see what happens if we change our sides to 4. So we'll unpause the experiment. We'll run it again with our sides equal to 4. And now this time we're placed into this square environment. And as we can see, if we pause and we look at the scene view window, we see that our enclosure has 4 sides. So basically, the sides dictate the shape. If we change it to 5, we'd have a pentagon. If we change it to 6, we'd have a hexagon. The next parameter that needs to be defined for an enclosure is the radius. And the radius just dictates the size of the enclosure. So essentially, the enclosure is created using a circle of the radius that you define, and the walls or the sides are placed tangent to that circle. So if we want, we can increase the size of our enclosure. Maybe we'll make it 25 instead of 15. We'll save that. Then we can go back to the Unity window, press play. And this time when we run the experiment, we see that our enclosure is much bigger than it was before. Okay, great. Let's move on to wall height. This is pretty intuitive, but this just changes the height of the wall. So if we change this from 3 to, let's say, 8, we run our experiment again after saving the configuration file. Now when we run the experiment, we see that our walls are much higher. Great. You can also change the color of the walls, and this color code is just an HTML color code. 6Fs is just white. We could change this to red by changing it to FF0000, so we just have full red, no green, no blue. And if we save that, run our experiment again, we'll see that our wall colors are now red. As you'll notice as well, with our enclosure, we do have this tiled flooring. So if we want to manipulate the tiling of the flooring, what we can do is we can use the parameters below to do that. So ground tile sides acts exactly like the enclosure sides. So let's say we change that to 40. That'll make it circular. We can also change the size of the tile. So right now it's at 1. This number has to be somewhere between 0 and 1. If we increase it to, let's say, 0.5, and we'll also just change our ground color, which is the color of the tiles. Let's change that to blue. And we can do that just by setting the blue indexes of our code to F. And if we save this, run our experiment, yep, and what we see is what we expected to see, which is we change our ground tile sides to 40, so they're very circular-like, reduce the size of our tiles so they're much smaller than they were before, and we change the tiles to be blue. And the last parameter you have to define is just the position of where the enclosure is, which is pretty intuitive. It's just the XZ coordinate of where you want it to appear in your environment. So now that we know how to create an enclosure, let's create our second enclosure for our second block, enclosure 2. We see that trial 4 and trial 5 are calling our enclosure 2. So let's go ahead and create another enclosure. You just do that by copying our first one and pasting again. And I'm just going to revert back to the original enclosure for enclosure 1. Keep the sides at 4. Radius can be 15. We'll decrease the wall heights again and set them back to white. And we'll set the tiling back to 0. And we'll make that square again. So now we have a square kind of enclosure up here, and we'll make a circle enclosure down here. So we can do that just by manipulating the sides. Make it 40 sides. We'll make the radius the same as above, 15. Wall height will keep the same as the above as well. Keep our white walls and black tiling. Now we have a square-like enclosure and then a circle-like enclosure. And also what you should note is that in our enclosure 2, we have active goal 2 instead of active goal 1. So this is just going to call the red cube somewhere else in the enclosure. And so let's just add to our block order. We'll run both blocks. We'll take our end trial off. We'll keep it on the second block. Save that. And then when we go back to run our experiment, see that we're first put into our square enclosure. Take note of where the cube is in this far corner here. go over now, it's invisible. One more invisible round. Okay, and now we're going to be placed into our circle-like enclosure. And we see that we are. And we see that the cube is now in a different location within the enclosure. And what you noticed on these trials is that we're actually being placed randomly within the enclosure. And that's because if we pause the experiment for a minute and we go back to trial 4 and trial 5, you see that we have the start position set to -1 and the start facing set to -1. And when the start facing and start position are set to -1, this will just place the participant into a random location and at a random start facing within the enclosure. So as you can see, you can very easily create a variety of different enclosures and call them into your trial. And we could just as easily use our other scene. So if we wanted to, we could change this to scene 5. And doing that, running our experiment again. We see that instead of the enclosure being generated in our 3D environment 1, it's now being generated in our 3D environment 2. So as you can see, it's very easy to manipulate local features while maintaining the global, or maintaining local features while manipulating the global environment. So these local enclosures can be super helpful for a variety of experimental tasks. Okay, and the last thing I want to show you is you can also use invisible enclosures to restrict your participants' movement to a specific part of your environment. And you can do that by going down to the enclosure, and instead of setting wall height to white, we're going to set it to transparent. And you can just do that by adding 2 zeros to the end, so 6 Fs and 2 zeros. And then we'll save that. And you'll see that when we launch our experiment configuration file again, this time it doesn't appear that our environment has an enclosure, but if you start moving around, you'll notice that it does indeed have an enclosure that we can't move beyond. And if you want to see what that actual enclosure looks like, we can just pause the experiment and we can go to the hierarchy view window. And these are all just the walls that are being generated for our enclosure. As we can see, here's our enclosure. And if we go back down to the game view window and we walk around, we'll see that we're going to hit a wall soon. We do. We're going to hit another wall. There we go. So this is a good feature if you want to have an open world type environment, but you also want to restrict the participants' movement to a certain area of that environment. That's it for this tutorial. I hope that it's been helpful. Again, if you have any questions, feel free to leave them in the comment section below the video.